What specific problem does the COT Encyclopedia aim to solve regarding the understanding and control of reasoning strategies in large language models?
The COT Encyclopedia aims to address the limited understanding and control of reasoning strategies employed by large language models, LLMs, during long chain of thought, COT, reasoning. Prior analyses primarily utilized top-down approaches with predefined strategy categories, which constrain the exploration of diverse reasoning patterns. In contrast, the COT Encyclopedia employs a bottom-up clustering-based framework that captures and interprets a wide range of reasoning strategies without predefined constraints. This method not only enhances interpretability, but also allows for systematic control over reasoning strategies, leading to improved model performance across various benchmarks. Ultimately, it reveals insights into how training data format influences reasoning behaviors, thereby providing a practical foundation for tailoring model responses to specific tasks.
How does the proposed method of the COT Encyclopedia work? Illustrate it step by step, detailing key components and processes.
The COT Encyclopedia operates through a 5-stage framework designed to systematically analyze and control long chains of thought, COTs, involving multiple reasoning strategies. First, it identifies diverse classification criteria by prompting a language model, LLM, to brainstorm contrasting reasoning strategies, resulting in a set of criteria that capture various reasoning dimensions. Second, these criteria are embedded and clustered to reduce redundancy, creating a compressed set of semantically similar reasoning patterns. Third, for each cluster, the method generates contrastive rubrics that describe the strategies in detail, facilitating binary classification of new COT responses. Fourth, each response is classified under these rubrics, producing a binary matrix that summarizes the reasoning patterns. Finally, a natural language report is synthesized to provide interpretable insights into the reasoning behaviors exhibited in the COT outputs, enabling both analysis and practical applications for improving model performance.
Can you provide a simple yet illustrative example of how the COT Encyclopedia applies its clustering-based framework to classify reasoning strategies? Walk through an example of the classification process.
The COT Encyclopedia employs a clustering-based framework to classify reasoning strategies through a systematic 5-stage process. For instance, consider a set of chain of thought COT outputs from a language model. First, diverse classification criteria are identified by prompting the model to generate pairs of contrasting reasoning strategies, such as top-down versus bottom-up. Next, these criteria are embedded into a vector space and clustered using hierarchical agglomerative clustering to group semantically similar strategies. Each cluster is then represented by a medoid criterion, which is used to generate detailed rubrics that describe the strategies. Finally, each COT response is classified under these rubrics by assessing alignment with the identified strategies, resulting in a structured report that characterizes the reasoning patterns of the model's outputs. This process not only captures fine-grained reasoning differences, but also enhances interpretability and reproducibility in analyzing model behavior.
What are the theoretical or practical benefits of using the COT Encyclopedia over existing methods of reasoning strategy analysis in large language models?
The COT Encyclopedia offers significant theoretical and practical benefits over existing methods of reasoning strategy analysis in large language models, LLMs. Theoretically, it employs a bottom-up clustering-based framework that captures a broader diversity of reasoning strategies without relying on predefined categories, which enhances interpretability and allows for the discovery of novel reasoning patterns. Practically, it improves model performance by guiding LLMs to adopt more effective reasoning strategies, achieving performance gains of 2.5–8.3% across various benchmarks. Additionally, the COT Encyclopedia reveals insights into how training data format influences reasoning strategies, demonstrating that format has a more substantial impact than domain on model behavior. This adaptability enables the generation of models with tailored reasoning capabilities through linear interpolation, providing a systematic approach to control reasoning strategies for specific tasks.
How did the authors validate the effectiveness of the COT Encyclopedia method? Describe the experimental design, datasets used, and performance metrics that demonstrate its effectiveness.
The authors validated the effectiveness of the COT Encyclopedia method through a comprehensive experimental design involving multiple benchmarks, including GPQA Diamond, MMLU Redux, and Math 500 for reasoning tasks, and XSTest and WildGuard for safety assessments. They extracted 4,057 contrasting reasoning criteria from model responses and applied hierarchical clustering to identify 6 reasoning dimensions, which were then used to classify model outputs. Performance metrics included accuracy improvements, with results showing increases of 2, 5 to 8, 3% across 3 different reasoning models, and human evaluations indicating a perceived reasonableness of 92 to 97% for their classifications, compared to only 51% for top-down labels. Additionally, they demonstrated that guiding models with optimal reasoning strategies significantly enhanced both accuracy and safety, with specific gains reported, such as an increase in GPQA Diamond accuracy from 72.7% to 79.1%. This robust validation process underscores the COT ENCYCLOPEDIA's ability to effectively analyze and control reasoning strategies in language models.
What specific results were achieved with the COT Encyclopedia method, and how do these results compare to previous approaches in terms of accuracy and interpretability?
The COT Encyclopedia method achieved significant improvements in both accuracy and interpretability compared to previous approaches. Specifically, it demonstrated performance enhancements of 2, 5 to 8, 3% across 3 different reasoning models on 5 benchmarks, marking the first instance of controlling high-level reasoning strategies to directly enhance accuracy. In terms of interpretability, human evaluations indicated that while top-down strategy labels from prior work were deemed reasonable in only 51% of cases, the bottom-up method of the COT Encyclopedia achieved a perceived reasonableness of 92 to 97% across various stages. This indicates that the COT Encyclopedia not only captures fine-grained reasoning differences more effectively, but also provides clearer and more coherent analyses than traditional methods. Overall, these results highlight the COT ENCYCLOPEDIA's superiority in both enhancing model performance and offering deeper insights into reasoning strategies.